we have a non-homogeneous equation. The left-hand side will come from a Cauchy-Euler equation, and we can solve it. But this problem, we are given that x to the 9 and x to the 10, all of them are a solution set to the homogeneous equation. So with that, we can say the homogeneous solution we have y1 equal to x, y2 x to the 9, and y3 x to the 10 power. And then the linear combination of this is the homogeneous solution or the complementary solution. C1 y1, C1 y2, C2 y2, and C3 y3. So C1 x, C2 x to the 9, and C3 x to the 10. Now we go to particular solution. And we're going to use a variation of parameter. So in that case, the particular solution will be in the form of V1 y1, V2 y2, and V3 y3. And then that V1, V2, V3 prime will be in terms of the system of equation. Right. Let me just write that real quick. So the system of equation that we're going to have is we're going to solve for V1, V2, and V3. This is a long problem, so we skip that step. We're going to write on the wrong skin. So first, we have W, wrong skin will be Y1, Y2, and Y3, and then the derivative. And we need the second derivative, so we will have a square matrix. Second derivative. The 3 by 3 determinant. So we will have x, 1 and 0, x to the 9, 9x to the 8 power, 72, x to the 7, x to the 10, 10x to the 9, 90x to the 8. And this is the 3 by 3 determinant. All we need to do is just evaluate that along the first column. I'll use the first column. So for x, if we cover the row of column of x and the row of x, that's what we got left with. And so I should go back and not do that. So I have 9x to the 8, 10x to the 9, 72, x to the 7, 90, x to the 8, and then minus 1. We evaluate along the first row and the first column, and the submatrix when we cover the row and the column that containing 1, so we cover the row and column that containing 1, and we left with the 2 by 2 submatrix of x to the 9, x to the 10, 72, x to the 7, 90, x to the 8. Right? Evaluate this. We should have we have x. Inside we'll have x 90 x to the 17. 90 times 9 will be 810, and all of that when we clear out it will be 90 x to the 17, x to the 16, and then would actually be x to the 17. And then minus, now we have 90 minus 72, that will be 18, x to the 17, and when we combine these two we should have 72, x to the 17. So that is the wrong skin. Next, we're going to do W1, W2, and W3. Right, for W1, for W1 we will replace this column that's corresponding to Y1. Instead of that column, we're going to write zero, 0, and then the input function. Notice that for variation of parameters, the coefficient, the first one has to be equal to 1. So if we have to divide by x cubed both sides, we have to do that, so the coefficient for y cubed is going to be 1. If we do that, the right hand side is x cubed, and that's what we're going to put here, not x to the 6. It's just x cubed. Because for variation of parameters, the coefficient, first the leading coefficient has to be equal to 1. Right, and then the rest of the problem will be the same. We just say x to the 9, 9x to the 8, 72, x to the 7, and then x to the 10, 10x to the 9, 90x to the 8. And we evaluate based on the first column. Notice that the sign chart for the 3×3 determinant, we're going to have plus, minus, and then the plus. So the x cubed, we carry the positive sign. And that's why we just have x cubed. And then just the 2×2 determinant. The subdeterminant will be x to the 9, x to the 10, 9x8, 10x to the 9. And do that, we should get inside, we have x cubed, and then 10x to the 18 minus 9, so it will be x to the 18, so have x to the 21st power. Right, and then for W2, we will replace the second column by 0, 0, and then x cubed. Sorry, I don't know why I write x3. The other two columns will stay the same. Right. Now the sign chart. We start with the plus. So there will be minus, plus, plus, and then minus. So that x cubed will carry the negative sign. Right. Now just go back and erase all of that. the sign alternating just like the chessboard. So the x cubed is negative x cubed. The subdeterminant we have is x1, x to the 10, 9x to the 9. And we have negative x cubed, 9x to the 10 minus x to the 10 to that ax. Sorry, I don't know why I put the 9 here. This should be a 10. So we have 10x to the 9. Alright, so inside 10x to the 10 minus x to the 10 will give us 9x to the 10 power. And so we have negative 9x to the 13 power. And then W3. x1, 0, x to the 9, 9x to the 8, 72x to the 7. And then the last column will replace by 0, 0, x cubed. And the sign chart will corresponding will be a plus sign, so it will be x cubed. And the sub matrix x and 1, x to the 9, 9x to the 8. And if we do that, we have x cubed, 9x to the 9 minus x to the 9 is ax to the 9 power. Multiply, we have ax to the 12 power. So we found on the wrong skin the W, W1, W2, and W3. With that, we can say we switch to different color. There's a lot of space here. V1 prime will be equal to W1 over W. W1 is x to the 21st power over 72 x to the 17, and we have 1 over 72 x to the negative positive 4 power. Integrate and we get back to V1. And that gives us 1 over 360 x to the 5th. Right, and then we do the same thing for V2 and V3. W2 is negative 9 x to the 13 and 72 x to 17 is W, and so we have negative 1 over 8 x to the negative 4. Integrate and we should have V2, and that will be negative 1/8 multiplied by negative 3, so that will be 1 over 24 x to the negative 3. We just integrate. And same thing for V3, W3 over W. W3 is ax12 over 72x to 17, and that will be 1 over 9 x to the negative 5, and integrate. We should have 1 over 9 times negative 4, so negative 1 over 36 x to the negative 4. So that all the V1, V2, and V3. With that, we're going to put into the particular solution. V1, Y1, V2, Y2, and V3, Y3. So V1, 1 over 360 x to the 5th. Y1 is x. V2 is 1 over 24 x to negative 3 times x to the 9. And then negative 1 over 36 x to negative 4 times x to the 10th power. Good thing is that all of them has the x to the 6th power, and then we just add all the coefficients. We should get 1 over 60 x to the 6th power. And that is our particular solution. And put all of that together, we have the general solution. Will be complementary solution and particular solution. So C1, Y1, C2, Y2, C3, Y3, and then the particular solution. So that's what we have. Let me zoom out. So we have the whole picture. Right. So again, the homogeneous solution, we are given that. So that's easy. Our particular solution, we use a variation of parameters. Find on the wrong skin on the W's, and then Cramer's rule, we find on the V. Sorry, this has the derivative. On the derivative by Cramer's rule, and then we integrate, we have on the V's, and then the particular solution is V1, Y1, V2, Y2, and V3, Y3, and we have that. The general solution is the complementary solution plus particular solution. And that's what we have.